Hello everyone, today we are going to use this lesson to go through the radian measure. Okay, if you're ready, please follow me. Okay, we have used the term degree since primary school to measure angles, right? For example, 30 degrees, 40 degrees, so on and so forth. Just like we are also comfortable in measuring distances using meters. Some of the Americans are used to miles, feet, inches. We are more comfortable with meters, centimeters, kilometers, etc. Okay, just like distance, right, which can be measured in different units, angles can also be measured in different units. We are used to degrees, but actually we have other units available as well, which is what we're going to learn today. Okay, so before we carry on, maybe you can think about two ways. You can instruct a friend, right, to turn and face a particular direction you want them to. For example, now your friend is looking in this direction. Can you tell your friend to face some other directions? Okay, there are various ways. I can tell this person to maybe turn to his 2 o'clock. Okay, to turn to his 2 o'clock, this is 12, this is 3, 2 o'clock is here. I can ask him to turn to this direction. That's one way. Other ways includes like turn half right. Okay, these are not very specific instructions lah, but it doesn't matter as long as it gets the work done. Okay, so knowing that, right, we have other ways of measuring angles, and we'll find out why is it useful to learn about this radian measure particularly. Alright? Okay, so now we are going to look at a circle with a radius of 1 unit. It could be 1 meters, 1 cm, 1 kilometers, doesn't really matter. So for convenience, right, I'm just going to call this 1 meter. Alright, so I have a circle of radius 1 meter. Okay, let's write down the circumference of this circle. How do I find the circumference? There's a formula, right? The circumference is equals to 2 pi r. In this case, the radius is 1 meters. 2 times pi times 1 simply gives me 2 times pi, right? 2 times pi. I can press the calculator, but over here they tell me to leave my answer in terms of pi. Okay, so my circumference will just be 2 pi units. Okay, so this circle has a circumference of 2 pi units. Alright, so what is going to happen now is I'm going to imagine a man standing here at the center of the circle. So this man is going to walk along this radius until he reaches this point. Okay, so on the second circle, the man would have walked from here to this point. And the next important thing is this man is now going to walk 1 meter along the circumference of the circle. 1 meter. So this is 1 meter, this is 1 meter. Okay, and once he reaches here, he is going to turn and face the center again. And now he will walk 1 meter towards the center of the circle. So now basically I form this shape. Okay, 1 meter, 1 meter, 1 meter. Alright. Okay, notice that after I form 1 meter, 1 meter, 1 meter, I will enclose an area and I actually end up with this angle which I can measure. Okay, I'm not going to measure it right now. I'm just going to call this angle X. Okay, I don't really care how big it is. Let's just call it angle X first. Okay, what's going to happen is now this man is right at the center, right? I'm going to make him walk back again. So now he'll be here. And then he is going to walk along the circumference again for another 1 meter. Okay, and then now he'll be here. So what he's going to do now is to turn and face the center again and walk 1 meter back towards the center of the circle. By doing this, I form this thing. X, angle X, angle X. This is worth 1 meter. This is 1 meter. This is 1 meter. Okay, so right now we're just going to call this angle X. Okay, so basically, right, how many times more can we do this before we form one complete circle? Would you like to make a guess? Okay, let's take about maybe 5 seconds to do that. Okay, so I'm gonna do I did a rough drawing over here, right? So another 1 meter over here, another 1 meter over here, 1 meter over here, 1 meter over here. So how many do I have? 1, 2, 3, 4, 5, 6. And then I have a bit more. Okay, so how many times can we repeat this process before I cover the entire circle, right? My estimate is maybe 6 or 7, maybe 7. So, or maybe 6 to 7, around there. Okay, so now let's try to fill up this table. This table talks about the angle x. When the angle here is x, what is the arc length here? I can just copy, right? When this is x, the arc length is 1 meter. Okay, now when the angle is now 2x, I can see quite clearly, right? This will give me an angle of 2x. When this angle is 2x, what can I say about this arc length? Okay, you see for yourself, this is 1 meters, this is 1 meters. So if I have angle 2x, my arc length here will be 2 meters. Okay, so I'm just going to write down without the units. Can you tell me what's the answer going to be for this blank over here? If the angle is 3x, what can I say about the arc length? 3x, the arc length is going to be 3 meters. Okay, so I'm going to repeat this process, okay, until I cover the entire circle. So when I cover the entire circle, what is the length of the entire circle? This actually is the circumference of the circle, right? So the circumference of the circle, I've already found it right from the start. The circumference is 2 pi. Okay, so when the arc length is 2 pi, okay, when arc length is 2 pi, what can I say about this angle over here? So it should be quite clear to you, right? When the arc length is 3, the angle is 3x. When the arc length is 2, the angle is 2x. When the arc length is 1, angle is just x. So what happens when the arc length is 2 pi? To answer this question, I just need to ask myself, what is the angle going to be when the arc length is, say, 3.5? 3x. 3.5? 3.5x. 2 pi? 2 pi. Alright, so 2 pi x, 2 pi of this angle x will give me 1 full round. Okay, so let's turn to the next page. Okay, so now we are ready to define formally what is the meaning of this radian. Okay, from now on, we will call this angle x that we talked about so far, this we will now call 1 radian. Okay, what is so special about this radian? Let's look at this again. When the angle is 1x, the arc length is 1. When the angle is 2x, the arc length is 2. So on and so forth. So actually, the radian is the angle that produces an arc length that is equal to the circle's radius. Okay, is the angle that produces an arc length that is equal to the circle's radius. Okay, for example, if this is 1 radian and this is 1 unit, this arc length will also be 1 unit. If this was 2 meters and this is 1 radian, this arc length here is also going to be 2 meters. Okay, so this is the idea behind using the radian as a measure, because it's really very convenient. Okay, so basically with the radian angle over here, the arc length can be found simply by looking at the angle. Okay, why do I say so? Because we have an example over here to illustrate it. The circle has a radius of 1 unit. Over here, 1 unit. The angle of the minor sector is 2 radians. Okay, there are 2 sectors over here. This is the first one, this is the small sector. You can imagine a sector as a slice of pizza. Okay, so there's a smaller slice of pizza called the minor sector. There's also a bigger slice. The bigger slice is here. So this is the bigger slice called the major sector. So in this question, they're talking about the angle of the minor sector over here. This is 2 radians. Okay, the short form for radian is simply written like that. Okay, so this is 2 radians. So now, in order to find this arc length, it's actually quite simple. I can cut this into 2 equal pieces. So each angle is going to be 1 radian. So if it's 1 radian, this part is going to be 1 unit, correct? Because this is the meaning of 1 radian. 1 radian, 1 unit, so the arc length is going to be 1 unit. Similarly, this one is also going to be 1 unit. So can you tell me what is the arc length of the darker portion? Very simple, right? 1 unit, 1 unit. So the arc length is 2 units. Okay, so I'm going to show you yet another example over here. The circle has a radius 2 units. Now this time 2 units. Okay, the angle is 1 radian. Over here is 1 radian. What can I say about this arc length? Okay, by the definition over here, 1 radian is the angle that produces an arc length equal to the circle's radius. My radius is now 2 units. So what can I say about this one? Definitely it's going to be 2 units. Okay, so the shaded arc length, okay, please ignore this. This arc length is 2 units. Okay, so it's really very convenient. If I measure in radians, I can tell the arc length really quickly. So as you can see, right, the arc length is related to both the radius, because when the radius change, the arc length also change, as well as the angle over here. When I increase the angle, the shaded arc also changes. Okay, so there are 2 factors affecting the arc length, okay, and they are the radius and the angle. So how are they related? Okay, what if I have one that is 3 units? Okay, if the radius is 3 units, obviously the arc length is also going to be 3 units. 5 units, 5 units. If I increase the angle over here to 4 radians now, this thing is now going to also occupy 4 units worth on the circumference. Okay, so actually there's a direct relationship, and the arc length, which we'll now call S with a letter S, is related to the radius r and the angle theta by this formula. The arc length is given by the radius multiplied by the angle theta. Okay, and this is an important result because it can help us solve many problems. Okay, using this formula, we are going to look at this question now. Example 1, find the arc length of the shaded sector. Shaded sector is here. Okay, I have the radius 4 cm. I have the angle over here 1.4 radians. Okay, so using this formula, S is equals to r theta, I will be able to find the arc length over here, S, very conveniently. All I need to do is to multiply the radius, which is 4 cm, by the angle over here, 1.4 radians. That will give me, if you do your mental sums quickly, 5.6 cm. Alright, so let's try exercise 1 by yourself, and I will go through in just about a minute. Okay, you might like to pause the video and unpause once you're done. Okay, I hope you're done by now. Let's check your answer. To find the arc length of the minor sector, this is the minor sector we are talking about. This is called S. Okay, arc length S. So using the formula, S is equals to r theta. The r in this case is 5 cm. The theta over here is 2.3 radians. So using mental sums, you can get your answers very quickly. Alright, it's quite simple, right? Okay, let's move on to example 2. Okay, example 2. What is the difference between questions in example 1 and example 2? In example 1, I see a full circle, and then from the full circle, we show you this pizza slice. Okay, in example 2, there's no more full circle. Okay, a pizza slice is shown to you straight away. So what I can do, right, is I just imagine lah. Okay, imagine that there's a full circle. Okay, but it doesn't really matter. Okay, it doesn't really matter. All I need to know is this is a sector. Okay, and we can carry on from there. Sometimes the angles is given to you in a weird unit. Okay, it doesn't matter. I see this thing over here, I see this thing over here, I will just imagine this is some number. Okay, what number is that? I can just press my calculator. Pi over 3. So it is this ugly number for the angles over there. Okay, doesn't really matter. Now I want to find this arc length. Okay, how do I do it? Same way. S is equals to r theta. The radius is 8 cm. The angle over here is this number, which is what I found over here, 1.04719 something something. Okay, so multiply by 1.0472. Okay, so I multiply this number by 8, I will have 8.38 cm. This is corrected to 3 significant figures. Alright, please try exercise 2 by yourself, and you might like to pause the video until you're ready. Okay, let's go through exercise 2. I want to find this arc length S. So using the formula S equals to r theta. My r here is 12 cm. The angle over here is 0.716 radians. Okay, so doing that quickly with the calculator, 0.716. My answer is 8 and 74 over 125, or I can leave my answer like that, 8.592 cm. Do I need to correct to 3 significant figures this time? Don't have to, because the calculator gives me an exact value, right? The answer is 8.592 exactly on the calculator. 12 times 0.716. It doesn't go on and on, right? Okay, it doesn't go on and on, so it doesn't matter. I can just keep it to these 3 decimal places. I don't have to round off. When do I round off? When I have numbers that go on and on. For example, I have a pi over here. Okay, if I press pi on the calculator, it goes on and on. So that's why I corrected to 3 significant figures over here. Okay, now let's look at example 3. The circle has a radius of 2 units. Okay, the minor arc length here is 2 units. Okay, find the angle in radians. What is this angle over here? Subtended at the center from the minor arc. Okay, so this is the angle that I'm interested in. Okay, if you're careful with the definition of radians, right? 1 radian is the angle that produces an arc length equal to the circle's radius, and you notice that the arc length is 2 units, the radius is 2 units. This one must be 1 radian, right? That is if you're careful with the definition. But you know, sometimes we are not so careful. Doesn't matter. I can always rely on this formula. Okay, by now you should be familiar that S is the arc length, which is 2. The radius is given 2. Angle, I'm not sure. Okay, but this becomes a Sec 1 question. 2 equals to 2 theta. I'm interested in the angle, so which is theta. So theta is just 2 over 2, giving me 1 unit. Sorry, 1 radian. Okay, very simple. Can you please try this one by yourself? Okay, let's look at the answer. The radius is 0.5 cm. The arc length is also 0.5 cm. So find this angle over here. S equals to r theta. S is the arc length, 0.5. Radius is 0.5 theta. Therefore, theta is 1 radian. Alright? Okay, so if you look back to page 1, okay, at the bottom, you will see that, for a full circle, the circumference is 2 pi, causing the angle to be 2 pi x, and x was 1 radian, right? We already defined it over here. X is 1 radian. So now what is going to happen is we now realize that going 1 full round is the same as going 2 pi radians. Correct? In primary school, we are also taught that going 1 full round is the same as 360 degrees. So what we want to be sure of is that 2 pi radians and 360 degrees are actually measuring the same things. Okay, so right now this is what I can write down. 2 pi radian is the same as 360 degrees. Okay, so naturally we'll have a question. 1 radian will give me how many degrees? Okay, how do I do that? Very simple. How do I move from 2 pi to 1? Just divide by 2 pi, right? Same thing over here, divide by 2 pi. If you press your calculator, 360 divided by 2 pi. That gives me 57.295 and so on and so forth. So now I'm going to correct this to 1 decimal place for angles, 57.3 degrees. 57.3 degrees. So 1 radian is approximately 57.3 degrees. So as you can see, right, all these angles, 1 radian, okay, this angle is about 57.3 degrees. This one is about 57.3 degrees. Okay, so going the other way around, if I started with 360 degrees, I know that this 360 is the same as 2 pi radians, right? 2 pi radians. So my natural question is, 1 degree, how many radians is that going to be? Okay, so how do I move from 360 to 1? Very simple, divide by 360. Same thing over here, divide by 360. So 2 pi divide by 360, that gives me 0.01745, so on and so forth. 0.0175 radian, okay, to 3 significant figures. Okay, so now we actually form an equivalence. 1 radian is about 57.3 degrees, okay, and 1 degree is about this many radians. Okay. So now let's look at the following page. Okay, I'm supposed to go and convert these angles from radians to degrees. That's quite simple. How do I do that? 0.5 radians, how many degrees is that? I can always start with this. 2 pi radian is 360 degrees. So 1 radian must be 360 over 2 pi. And therefore, 0.5 radian is the same as 360 over 2 pi times 0.5. And then I press my calculator. 360 divided by 2 pi times 0.5. That gives me about 2.864. But since we are looking at degrees, right? Degrees will keep to 1 decimal place. So that's 2.9 degrees. 2.9 degrees. Okay, alternatively, some of you may choose to remember that 1 radian is about 57.3 degrees, right? Okay, so therefore 0.5 radian is just this thing over 2. Okay, so that gives me 28.6 degrees. Okay, I'm sorry, this one was a mistake. I multiplied by the wrong number over here. So let me try that again. 360 divided by 2 pi times 0.5. So it's 28.6. Okay, I get the same answer. 28.6 degrees. Okay, can you please try exercise 4 by yourself? Okay, let's go through. 1 radian is 360 over 2 pi. So 0.8 radian is just 360 over 2 pi times 0.8. And that gives me, let's check, 360 divided by 2 pi times 0.8 gives me 45.8 degrees. Okay, this one, do when you have the time. Next one, 1.5 pi radians. Okay, now this time the angle is given in terms of pi. No worries, I always know that 2 pi radian is 360 degrees. Okay, so 1 radian is 360 over 2 pi. And therefore 1.5 pi radian is the same as 360 over 2 pi multiplied by 1.5 pi. Okay, you might want to do some cancellation. You realize that this pi and this pi can cancel each other out. Okay, so 360 divided by 2 pi times 1.5 pi. So the answer is 270 degrees. Very nice answer. Okay, please try this by yourself. Okay, let's take a look. 1 radian is 360 over 2 pi. Okay, why do I not use this one, right? Why do I not use this? Because this one is rounded off. Okay, this one is rounded off. It came from here. 360 divided by 2 pi rounded off. Okay, so what I'm going to do now is to use this exact form and then look for the answer for this question. 360 over 2 pi multiplied by 0.35 pi. Okay, so we can press our calculator. 360 divided by 2 pi times 0.35 pi. Okay, answer is 63 degrees. exactly. Alright. Okay, last part before we end off this section. Now that I can convert from radian to degree, I should be able to do the other way around, right? So 50 degrees, I want to convert to radian. How do I do that? 360 degrees is the same as 2 pi radian, right? One full round. Okay, so now to find 50 degrees, all I need to know is find 1 degree first. 2 pi over 360, and therefore 50 degrees is the same as 2 pi over 360 times 50, and that gives me, let's see how much. 2 pi divide 360 times 50, 0.873 radians to 3 significant figures. Okay, please try this by yourself. Alright, let's go through. 1 degree is 2 pi over 360 radians. So 85 degrees is the same as 2 pi over 360 times 85. 2 pi divide 360 times 85. So I get 1.48 radians to 3 significant figures. Right, so last part over here, example 7. Convert the following from degrees to radian, leaving your answer in terms of pi. That means in my final answer, I want to see pi. How do I do that? Quite simple. I know 360 is 2 pi radian. So 1 degree is 2 pi over 360. Okay, and therefore 120 is 2 pi over 360 times 120. That gives me how much? 2 pi divide 360 times 120. Oh no, I get an ugly number. So what I should have done is exclude the pi from your calculator. Okay, get rid of the pi. Take 2 over 360 times 120. Okay, I get 2/3. Okay, this means that the pi has been removed. I just put it outside. The numbers by themselves gives me 2/3. So it's 2 over 3 pi. That's it. Okay, of course in radians. Let's try the last one by yourself. Okay, so let's look at the answer. 360 degrees is the same as 2 pi radians. To get to 30 degrees, some of you can jump a few steps, don't worry, that is also acceptable. I'm just doing it step by step. 30 degrees is the same as 2 pi over 360 times 30. Okay, so when you press your calculator, just remove the pi. 2 over 360 times 30. So you get 1 over 6. So that gives me 1 over 6 times pi, which is the same as pi over 6 radian. Alright. Okay, the answer over here is not correct. Okay, the answer over here should be, let me see. Okay, so 1 degree is the same as 2 pi over 360. So 250 degrees is the same as 2 pi divide 360 times 250. 4.36 radian. Alright, so that's all for the e-learning for this session. Okay, the remaining parts will be done separate on a separate session. Okay, thank you for your attention so far.